So now that I have the basics of my scene set up, I have this real simple platform. I have a sphere and a couple of obstacles. I'm going to take control over this sphere. The whole concept of this project is that we want to create a third-person project. We're going to use a sphere to begin with, and we'll ultimately kind of, layer some mechanics onto that. But we want to take this iterative approach to game design, which means we start designing our game and we take little steps at a time, testing as we go. So the basic concept here is we want to take control over this sphere. And now, in order to do that, this is going to be a little different than our first-person game in that we need to be cognizant of our camera. I'm going to select the main camera. I'm just going to take a quick look at our composition. Now, it's pretty low to the ground. I ran the play button before, and I see that my main camera is not exactly where I want it. So just to continue this demo, what I'll do is I'm going to select the main camera. I'm going to modify this by rotating it downwards. So I'm just going to point it down. I'm going to roll, up its X value. I'm going to lift the camera up. I'm going to move it over just a bit. And then I'll just kind of rotate it along the Y-axis to point a little bit to the left. Now, I'm going to modify this later, and ultimately our camera is going to follow around our sphere here, but I just want to create some basic mechanics to get this thing up and running. Now, I'm going to use Playmaker to start to control this sphere, and rather than call it sphere, I'm going to start to refer to this as our player object. So I'm going to name it player, and much like we did in the Gravity Lab project, I want to take control over this object through physics. And so I'm just going to set up a real quick scenario where I apply a rigid body to this object. So what we'll do is I'm going to lift my player character up just a little bit, and this is going to do a couple things. It's going to ensure that my rigid body is functioning before I take control over this object. So I'm lifting up the object, I'm going to go to components, and I'm going to choose physics rigid body. I'll hit the play button, and as I would expect, the player character falls to the ground. Now, I want to control my player object, and I want to do that by applying force to this object. Now, this object is arranged that roughly this is the Z space, the way that my mouse is moving. Left to right is X, and then up and down is Y. And I can confirm that when I go back into my game project and look and pay attention to this widget. Now, by default, what I'm going to do is I'm going to create a control system that maps the control of this player to the Z X plane. Okay. Now, when we do that, ultimately this design is going to be up to you, whether you look through a perspective camera and you control your sphere with a fixed camera or something that tracks the player character, or we do something more like a third person over the shoulder kind of feel. And we'll explore a couple of different ways to control our sphere. But just to get our basic mechanics set up, we're going to start just by taking really basic control over the sphere. Now, I'm going to make sure that the player character is selected, and I want to start to take control over this with Playmaker. So I have Playmaker configured. I'm looking at my Playmaker editor here. Over on the right side, I have my action browser. And I've taken the time to save this layout as the Playmaker layout. So again, if I go back to my default setup, this is the default setup in Unity. I've already saved my setup as Playmaker by choosing Save Layout. I've set up my layout. And I've saved it. So I'm going to go back to my rough perspective view here. Roughly the same perspective that the camera is looking at. I'm going to make sure my player character is selected, and I want to control the player. So what I'm going to do is I'm going to right click and start by adding an FSM. Now, the state machines inside Playmaker, we're going to take a look at some of these other tabs. The FSM tab, this is the place where we label the state machine, and it's going to be very common for us to have multiple state machines attached to the same object. So we want to start labeling our state machines. So I've added the state machine to the player character. I can tell a couple different ways. If I look in the hierarchy manager, I see that it has a little developer tag here. Also with the object, the player object selected, if I look over in the inspector panel, I can see that there's a Playmaker FSM script. The title of it is currently FSM. Not a very user-friendly name, so I'm going to say FSM. I'm going to add player control to the title. When I do that, you can see that in the background of the Playmaker editor, it adopts that name. Also, if I look over here in the inspector, I can see that that name has been inherited. So this FSM tag gives us the ability to look at or to rename the name of the state machine that's been attached. This will be helpful when we're managing multiple state machines. Now I'm going to go back to the state tab. On state 1, this state, I'm going to start naming these states very specifically so that I can troubleshoot and track what's happening on screen. Rather than state 1, I'm simply going to call this move, because this is the action where the movement is going to happen. Now the way that I'm going to create a movement script, I'm going to be very procedural. We'll just move through and follow this this recipe. The way that I'm going to get this sphere moving is I'm going to listen for some user input. So I'm going to go look at the actions panel, and I'm looking for an input. So I'm looking for the input tab. Here it is. Inside input, what I want to do is I want to do a get access vector. Now what get access vector is, I'll just double click to add that action to my move state. What the get access vector does is it talks to the controller, the control system inside Unity, and maps user input to a horizontal axis and a vertical axis. In Unity, it refers to the horizontal axis as anything that references the left-right movement of a player. And in the case of Unity, by default, the A and D keys are mapped to the horizontal axis. So in other words, if we're using a WASD setup, or kind of a standard first-person perspective, the A and D keys on the user input are mapped to the horizontal axis, while in the vertical axis it's mapped to WS. The horizontal axis is also mapped to the left and right key on the keyboard. Now, when it comes to user input inside Unity, you can remap these things just like you can any game that you play. If you decide to change the control system and you want to map, say, the horizontal axis to Q and E, you can do that through the player input settings. But for now, we just want to let things default. So we're listening for what Unity refers to as the horizontal axis and the vertical axis, okay, which by default is mapped to W, A, S, and D keys, or the arrow keys in the keyboard as well. Now, what's happening here is that we're listening for user input, and in order to get this action to work properly, we need to store this in a vector variable. So we need to create a vector3 variable. So I'm going to go over to my variables tab, and I'm going to create a new variable. And this is going to be, I'm going to call this player movement. I want to make sure the variable type is not set to float. And I want to remind you a little bit about creating variables. When we create variables, we always want to start off with the first character as lowercase so that we don't create any conflicts with any kind of other functionality within Unity or Playmaker. So the first letter is always lowercase, and then from there you can use uppercase or whatever you want. I'm using this Camelback name convention, which kind of separates the words with capital letters. And I've created a player movement tag or title, and the variable type that I want is not a float, but a special kind of vector3. Vector3 is a position variable. It's a position coordinate system that refers to the X, Y, and Z. So there's a lot of information that's kind of packed into this kind of variable. So I've created a player movement. I've chosen vector3 as the variable type, and I'm going to choose add. I now have a player movement vector3 variable, and I'm going to go back to my state. I have this get access vector action, and in the store vector, I'm going to choose my new player movement vector for that. Now, if you don't have your debug option turned on, I'm going to recommend that you do that. And if you don't have your hints turned off, I'm going to turn my hints on because this is the default setup inside Playmaker. And you may be looking at all of this information that gives us some really valuable hints, but I'm going to turn my hints button off. And I just want to remind you to do that if you haven't already done so. In addition to that, I want to turn on debug. And what debug is doing, you'll notice that whenever there's a variable, if I turn on debug, it's going to show me the value of that variable. Currently, my vector3, my player movement vector3, is just a series of zeros. Okay? But when I hit the play button, as long as I have this state selected, Now I'm going to pay attention to what's happening to the store vector or the player movement, and I'm going to press either the arrow keys in the keyboard or I'm going to press the AWSD keys. When I press the A key, you can see that that first value goes up to -1. I'm going to release the A key. I'm going to press the D key, and you'll see that that value goes to 1. So if I press the A, it goes in the negative direction to -1. If I press the D key, it goes to +1. If I press the W key, that last value goes all the way to +1. If I press the S key, it goes to -1. Okay? Now, the plane that we're mapping this to, this get access vector, is being mapped to a specific plane, which is X and Z. Okay? So the result is that when I press the W key, whenever we see a vector 3, we're looking at X, Y, and Z. If I look up here at the transform position, I have a position of X, Y, and Z. If I press the W key, my mouse is over the game window. If I press the W key or the S key, I can see these values changing. What I want to do is I want to translate this user input here that I'm generating in real time, and I want to map that to a force that's being applied to my player character. So I'm going to toggle the play button off, and I'm going to go back to my move action, and I'm going to add one more action to this equation, and that is a physics action. Now remember, I've taken my player and I've added a rigid body, okay, and that allows it to allows that component, that game object, to listen to the physics engine inside Unity. So what I'm going to do is I'm going to go and find the physics category inside Playmaker, and what I want to do is I want to do an add force. So I'll double click and I'll add force to my player move state. Now I'm going to lift my window up here so you can see all these actions. I'm doing a get access vector, and we're storing the user input into this player movement variable. What I want to do then is I want to take an add force and I want to apply whatever the user input is in this vector 3 position. There's a little vector 3 drop down menu. I want to use the player movement variable that I've created to apply force to this object. Now it's important that if I choose to add force and I choose this vector 3, the first action is listening for the user input and storing that in the player movement vector 3. The second action is using that user input and applying a force. That's what this action does. It adds force. Now if I hit the play button and I choose the AWSD keys, there's not much that's happening. Even though this store vector value is changing based on the AWSD, and I see down here in add force those values are changing. The little glitch that we have is that it only does that during the first instance. This action currently is saying apply force, but do it one time. If we check every frame, that means that it's going to apply this value of force to this axis every frame. So now when I hold down the W key, you can see that my ball slowly rolls in the Z direction, okay, because that is the value. When I hold down the W key, we're mapped to the XZ plane, and we're changing the Z value. We're using that vector 3, or that 3 position coordinate system, to add a force to the object that we have selected. Now, I'm going to toggle the play button, hit play again. Our player is not very responsive. If I hold down the A key, I can get it to kind of move to the left, and if I hold down the D key, I can get it to move back to the right. But you can see that it kind of takes forever for this thing to start moving around. Well, what we can do, if I toggle my play button off and I go back to my move action, you'll notice that when we're pushing the AWSD keys, the store vector, or the vector that we're creating, has a value of 0 to 1, and it's using that real value to apply force. So we're adding a force of 1 in Unity to our sphere. But what we can do is in the get access vector, we can add a multiplier. So currently it's set to 1. Now watch what happens when I set this to 5. I'll hit the play button. Now when I press the AWSD keys, instead of using a scale of 0 to 1, it's going to use a scale of 0 to 5. So now when I press the A key, you can see that my X value goes all the way down to -5, and then when I hold down the D key, it goes all the way up to +5. And you can see that the player character, my sphere here, is much more responsive. Not quite as responsive as I want it to be. Okay, so I'm going to toggle the play button. I'm going to go back to move, and I'm going to bump the multiplier up to 10. I'll hit the play button again, and I'm just going to play with this, and now I can see that it's really starting to become much more responsive. Now, as I push this sphere around, when I take my hand off the input keys, you can see that this sphere really kind of rolls on. It just keeps rolling because there's not much drag on this object. There's nothing inside the environment. Now, if we had a ramp or we're moving uphill or against gravity in some way, this thing would slow down quite a bit. But just sitting on top of the surface of the ground plane, there's not a whole lot of drag. What I can do is select the player character and go into the rigid body component and find the drag value and change that from 0. I can add a positive value. Now, if I bump this up to 1, this is the linear drag, or the amount of drag or resistance that this object is experiencing. Now, when I release the user, my input, my access keys, AWSD, you can see that that sphere starts to slow down much quicker. If I want it to slow down much faster, I'll take that drag value and I'll bump it up to 2 or 4. I'll bump it up to 4. Now, as I apply force, you can see that as soon as I release this, it comes to a much quicker stop. But it also requires a lot more force to move this object. So what I'm going to do is I'll go back into my state machine, I'll go find that multiplier, and I'll bump that value up. You can think of the multiplier as effectively the amount of force that we're applying to our player character. So I'll just play back and forth between the drag and the multiplier, and I'll try to get those values balanced so that this object is moving in different ways. Now, I'm not going to spend too much time trying to balance this and get this right, because again, the concept here is we're going to explore some of the basic mechanics. We're going to understand our capabilities inside Unity with Playmaker. We'll start building some obstacles and some basic mechanics, and then we'll start to think about, based on what we know, what kinds of levels can we design. So in the next presentation, make sure that you take some time right now to play with the concept of the player controller. In the next presentation, we'll start to build some basic obstacles, and then we'll come back and we'll revisit the player control and talk about some different camera options that we have. But we'll do those in upcoming videos.